Alright, so today we're going to be continuing our study of some of the harder topics in vectors, and specifically we'll be going over perpendicular and parallel vectors and how to test whether or not they are. So, the vectors u and v are perpendicular if u dot v is equal to 0. So that means that the dot product of u and v is 0. And if we think about it, that's actually not that surprising, considering what the dot product is, or at least one of the ways we can find the dot product. So previously we spoke about one of the formulas for the dot product being u dot v equaling the magnitudes of u times v times cos theta, where theta is the angle between them. And so if I look at my two vectors u and v, then when they're perpendicular, then my angle between them is actually going to be a right angle. So theta is going to be 90 degrees, and cos of 90 degrees is going to be 0. So this whole thing is just going to be equal to 0, because the magnitudes times 0 is just going to be 0. So that's where this arises. So it's actually not that hard to figure out yourself, but it's a really useful property because it lets us then test to see if vectors are perpendicular with each other. So let's look at some examples of that. So if we want to show that vectors u and v are perpendicular, we want to test that u dot v is equal to 0. How do we test that? Well, we could find the magnitudes, which we can easily find with the coordinates, and then test that the magnitudes times cos theta is equal to 0. But we don't know the angle. We expect that it's going to be perpendicular, but we have to use a different method to find u dot v. And what we're going to do is we're going to use another formula we learned for the dot product, which is that u dot v is equal to x1 times x2 plus y1 times y2. So this is the form where we multiply the components and add them. So this is the formula rather that you have to use to test to see if they're perpendicular. Because if this is going to be 0, then our vectors are going to be perpendicular. So let's test that now. So if we have u and dot v, then we're going to have our x1 and x2 as 5 times 3. That's 5 times 3 plus, and that's going to be minus 3 times 5. And that's going to give us 15. So this is going to be, this is going to be 15. And this is going to be minus 15. So that means that u dot v is going to be equal to 15 minus 15, which is 0. So therefore, u dot v equals to 0, and u and v are perpendicular. So now we've shown that they're perpendicular, and we've done that by testing the dot product, and we use this other formula for the dot product where we multiply the components and then add the multiples. So now let's look at some parallel vectors. So the vectors u and v are parallel if u dot v equals to the magnitude of u times v for vectors in like directions, or u dot v is equal to negative uv for vectors in unlike directions. Well, let's first talk about like and unlike directions. We've already mentioned this in the previous units on vectors, and if you don't remember what they are, I do suggest going back to those videos. But as a quick summary, if we have two vectors that are parallel, then that essentially means that if we extend the two vectors to infinity, they're never going to cross each other. So if we have two vectors with our directions pointing this way, then that means they're never going to touch each other because they're both going in the same direction. But we also have vectors that can be going in opposite directions that are still never going to touch each other because the gradients are the same, but they're pointing in the different directions. So that would suggest that we can have two kinds of parallel, ones that are going in the like direction and ones that are going in the unlike direction. So if they're in the same direction, they're like; they're unlike, they're in the opposite directions. So now that we know what they are, how do we get these formulas? Well, it's rather simple, and we just go back to that same formula that we used for the previous perpendicular equation. So if we have u dot v, we can say that the dot product is equal to the magnitudes times the angle between them, so our cos theta. So if they're in a like direction, that means there's no angle difference between them. They're pointing in the same direction and facing the same way. So that means that our angle theta is going to be 0. And if theta is 0, then cos is going to be 1. So we just get left with u, v, magnitudes, times by 1. So we just get that the dot product is the magnitudes multiplied. But if we've got an unlike direction, then the vectors are going to be pointing in opposite directions. So our angle is going to be a full 180 degrees going all the way around. So that would be, if we had our vector u and our vector v, then we'd have a full 180 degrees going all the way around. So that would mean that we'd have cos of 180, which isn't going to be 1, it's going to be minus 1. So instead of getting the dot product being u times v for the magnitudes, it's going to be the dot product is minus the magnitudes multiplied, which is where we get this formula for unlike directions. So we can use these two formulas to test if vectors are parallel, and we can also use them to test if they're in a like or unlike direction. So now let's look at an example of finding if they're parallel. So we want to show that vectors u and v are parallel, given that u is equal to 4i plus 3j, so this is using ij notation, and that v is equal to 6i plus 4.5j. So first off, what are we testing? Well, we want to test if u dot v, so the dot product, is equal to the magnitudes multiplied. And because it can be like or unlike, we want it to be either plus or minus. It doesn't matter which one it is. That'll just tell us how the two vectors are orientated with respect to each other. So first things first, let's find the dot product. So we want u dot v is equal to, and we're just like in the perpendicular question, when we wanted to find the dot product, we have to use the multiplication form where we multiply the components and add them, because we don't know the angles, because that's exactly what we're trying to find. So what we're going to do here is it's going to be 4 times 6 plus, and then the j components, 3 times 4.5. And if you put this into your calculator, you're going to get 37.5. So that is going to be our dot product. Now, we want to test to see if that is the same as the magnitudes multiplied plus or minus. So let's test that. First off, we have to find the magnitude, so we want to find our u, and we do that using our formula for it. So this will be 4 squared plus 3 squared. Now, this is a very common example, so I do recommend knowing it. But if not, put into a calculator and you should get 5. So that means that our u is going to be 5, or our magnitude of u is 5. And now finding the magnitude of v, we're going to get the square root of 6 squared plus 4.5 squared. And if you put this into your calculator, what you're going to get is 7.5. So now, the moment of truth, we want to find the magnitude, the magnitudes multiplied. So we go, this implies that u times v magnitudes is equal to 5 times 7.5. Finally, if you put that into your calculator, you should get 37.5. So that is our magnitudes multiplied. So what we find is that u dot v is equal to 37.5, which is equal to the magnitudes multiplied, therefore parallel and in like direction. And it's in the like direction because it's positive magnitudes, not negative. So what did you learn this lesson? You learned how to test to see if vectors were parallel or perpendicular, and you did that using the dot product. So I hope this lesson was helpful, and I will see you guys next time.